statistical process control, controlling the variability in a production process by measuring the range of a random sample, where the population standard deviation is known. 2-litre bottles of cola. Some bottles have slightly more than 2 litres, some slightly less. So there's variability in the volume of cola in each bottle. And we can measure the variability by looking at the range. So we take samples and we work out the range for each sample. This is part of our process control procedure. And then the range values are plotted onto a control chart to see what happens over time. So in this example, we have our population mean and population standard deviation. We're taking random samples of size 4 and we're calculating the range of each of these samples. Range is easier to work out and understand compared to standard deviation. So for that reason, it may be a preferred process control method compared to standard deviation. Not everybody understands what standard deviation is, but working out the range where it's the largest value minus the smallest value is simple. So we're going to calculate the upper and lower warning and action limits. Table 12 in the AQA formula book, and it tells you for range charts, multiply your population standard deviation with a D value. Here are the D values here. So our sample size is 4. So we're looking at these values here. We need to multiply each of these with the population standard deviation to work out these limits, like this. Warning limits, action limits. D times the population standard deviation. So these values are from here. And then drawing the control chart for range. Part B, we're given these samples, so we're going to work out the range for each sample and then plot that value onto the control chart. Our first sample, we have 4 values in the sample. The range is the largest value minus the smallest value. A range of 2. So sample 1, the range is 2. It's plotted on our control chart, and we can see the value is between the warning limits, no action required. Sample 2, the range is 11.1. It's above the upper warning limit, so we need to take another sample immediately. It's still a value that's below the upper action limit. It's in between these two. So take another sample. If the range of the new sample is outside the upper warning limit, then we stop the process and take action to reduce the variability. Sample 3, range 0.8. That's a small value. It's in between the lower warning and action limits. So variability has been reduced. So to maintain this improvement, we should take another sample just to verify that the process has improved. Sample 4, this is above the upper action limit. Stop the process immediately and take action. there is too much variability in the production process. Sample 5, so perhaps after stopping the process, after sample 4, and making improvements, making changes, our next sample is within our warning limits, so no action is required, so any improvements that were made have been successful. So when working with variability in the production process, range has the advantage of being simple to work with compared to standard deviation.